Good morning or afternoon, everyone. We only have 6 people in here right now. We're still waiting for more people to come in. We'll get started when there's around 10 people, hopefully. But yeah, so we have 5 minutes to just chill. Well, hopefully you guys are doing pretty well. Had a good long weekend, or not long week, but had a good weekend. Yeah. So hopefully you guys are enjoying yourselves so far. That's good. If you have any questions, comments, concerns, please let me know in the chat. But yeah, good afternoon, Chris. Good to have you join us. Good afternoon, Hart and Hans. Hello, Alexandra. We are at 7 people so far. So on Friday, my cord broke. So the end with the micro HDMI was broken. That's why I wasn't able to run our lesson on Friday. So we're gonna do Friday's lesson today. Good afternoon, Gia and Russell. Okay, so we're just gonna go over our graphing checklist. We're gonna go over our lesson for today, and that's it. So it should be maybe around a 30-minute lesson, maybe nothing too long. So should be okay. Shouldn't be too bad. All right. Just another minute, and then we'll get started. We're going to be continuing our 3.5 curve of best fit. So that would be page 15 and 16, which means we're almost done our package. Okay, so let's just get started. Okay, so let's kind of go over our graphing checklist. What I should be expecting from graphing. So instead of a test, I'll be doing an assignment, and it'll be kind of like a final assignment for your unit, and you're gonna hand it in the same way you handed in your quiz assignment. Okay. Good afternoon, Amir. So let's go over what I'm looking for in a graph. Right? Graphing is worth 6 marks, or no. My apologies. Graphing is worth 7 marks. So it's a total of 7 marks, which means we should probably go over what each of the 7 marks are again one more time. Okay? Your title should be Y versus X. Of course, you're not just copying this down. You write down what Y is and what X is. So you need your title. Your two more marks come from your axis titles for your y-axis and your x-axis. So that's 3 total. Scales, right? You need to write a break if you need it and have equally spaced out numbers. Number 4, plot your points. And then number 5, draw your line or curve of best fit. Okay, so this is a total of 7 marks, 5 things that you need to remember, and that's a total of 7 marks. Okay, so make sure you keep all of this in mind. This is what we went over on Thursday, because we had very few people here on Thursday. So we talked about curve of best fit. So let's kind of talk about this section here again. So we have this example of a graph here, and it says a weather forecaster measures and plots the temperature every 2 hours on a summer day. Hey Atreyu, good to have you join us. The temperatures decrease from midnight to 4 a.m., increase once the sun rises, reach a maximum in the afternoon, then decrease again during the late afternoon and evening. The points do not lie on a straight line, but appear to be related, and this relation can be called a curve of best fit. And so these points here that I drew in, you can't really draw a line of best fit. If I were to draw a line of best fit, it wouldn't be very nice, right? If I were to get as close to as many points as possible, this line is not that great, right? It's really far from all the other lines, but if we drew a curve, that would help approximate a lot of these things better. And we use these curves and these lines of best fits to estimate something that we don't have. So here, what time of day the temperature was the greatest? It was 3 p.m. because we're looking at the greatest temperature, which is up here. I drew a green dot to signify what that point would be, and then I figured out the time. And then for number 2, it was what was the temperature at 5 a.m. We find 5 a.m., which is this purple line here, and it touches the curve at that point. Okay, so this is what we went over on Thursday, and we had a lot of people missing, so I didn't want to go over too much. So let's move on into the bulk of today's lesson, right? A good majority. All right. So the high divers at Paramount Canada's Wonderland, not even Paramount anymore, but Canada's Wonderland perform competitive dives from a height of 21 meters. A diver's height is measured every 0.2 seconds. Okay. So let's ignore question A. Let's first graph it. Let's have some practice with graphing. Okay. So draw a curve of best fit, graph the data. So step 1 in our graphing checklist was our title. What's our title going to be? So when we have a table given to us like this, if it's horizontal, X will always be first, Y is always second. And we said our title is written in terms of Y versus X. So our title for our graph here would be height, which is our Y, versus time, which is our X. Okay? So that's our first thing. You need your title. Step 2, your axis titles. So down here, this down here, I know there's a little space here, but this would be time, right? That's our x-axis. And our y-axis over here on the left would be height. And so we're going to write that down. If it has units, make sure your units are in brackets in your title. Okay? Now, in this example here, I want you to not use a break. We're not going to use a break, mainly because we're going to be estimating. When we estimate here, at the very bottom here, we don't want to use breaks. We want to use as much space as possible, but no breaks. Okay? So, let's kind of go through what we need to do here. Graph the data, draw a curve of best fit. Perfect. Okay. So we have our two axes titles. We have our title. Next step is our scale. 0 is going to be here, right? And for our time, we need to go from 0 to 1.2. The good thing about this is that they are already equally spaced out. There's no repeating numbers. It's all equally spaced out. So let's just plot those points on our, or plot those on our scale here. Okay. So 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, something like that. So let's do that. Every 2 squares we'll do we'll do this. So 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1.0, 1.2, 1.4. And that's every 2 squares. And notice, if it's every 2 squares, I make sure I start on the second square. Okay? So there's our x-axis scale here. Okay? For our y-axis scale, we need to go from 0 to 21. Now, remember, the reason why we're going from 0 is because I said do not use a break. I'll try to specify here, like, don't use a break. So we're not going to use any breaks for this. Okay, so no breaks. So our spacing, let's see, 2, 4, 6, 8, 10, 12, 14, 16. No, we're going to have to go each one. So let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I'm just going to go every single square is going to be a increase of 2. So now that we have this graph, okay, I'm going to give you 3 minutes to plot your points. So use the table above and plot the points. I'll give you 3 minutes on the clock, right? And draw your curve of best fit as best as you can. So draw your best curve of best fit. Use a pencil because you might not do it correctly the first time. That's why it's called a learning, right? Learning experience, because we may make mistakes. So make sure you do that. All right, 3 minutes on the clock, and I'll see you in a bit. All right. Hopefully you finished plotting. So let's go over. Our first point is 0, 21. So 0 on the x, 21 on the y. So 0 on the x, 21 on the y, which is up here. Our next point is 0.2 and 20.7. So 0.2, 20.7. So that should be pretty close to my previous point, a little bit lower like that. Next point is 0.4, 20.2. So that will be closer to the 20 line now, like that. And then we have 0.6, 19.4. So 19.4 will be somewhere here. Then 0.8, 17.6. So 0.8 on the x, 17.6 on the y. We have somewhere here. Okay. Then 1.0 and 16. Thankfully, that's right on the line. And then 1.2 and 14, which is right here. Okay. So those are our points. And if we were to draw a graph, right? Or, sorry, not a graph, a curve of best fit, you would try to make a smooth curve as best as possible. Now, I would probably move it sideways like this because it'd be a little easier to draw. I draw something like this. That'll be as close of a curve as you're going to get, right? And it's going to take a couple tries. I had to go over it a couple times, right? That's what a pencil and eraser is for, right? So then we have here our graph here, our curve of best fit. So this total would be 7 marks. Your title, 1 mark. Your 2 axis titles, 2 marks. Your 2 scales, 2 marks. Your points, 1 mark, and then your curve of best fit is your last mark. 7 marks. Now that we have that, if I ask you, what trend do you see? What would be the words to describe the trend in question A here? What trend do you see in the data? Explain the trend. So would this be positive or negative? Type it in the chat if you know it. Positive or negative? Strong or weak? Linear or non-linear? Chris saying negative, strong, linear. Negative, strong, non-linear for Russell. Negative, non-linear from Ross. Alexandra's also saying negative. So we seem to be in agreement that it is negative. Camilla saying negative as well. Anna saying negative. Is it strong or weak? So negative would be the first word. Strong or weak? Hart and Han saying strong. Ross is saying weak. Rose is saying weak. Russell saying strong. Chris is saying strong. Rose changing his answer to strong. I don't know, Rose. Which one is it? Amir saying strong. So I think we have an agreement here. It's strong. And the last one, is it linear or non-linear? Linear or non-linear? So Russell said non-linear. Hart and Han said non-linear. Rose said non-linear. Amir saying non-linear. So I think a majority of us are agreeing that this is non-linear. Okay, so we have non-linear. Perfect. Good. Anna's saying non-linear as well. So we have an agreement. So it would be negative because it's going down. We have strong, right? Because the curve, the best fit line or curve is very close to the points. And non-linear because it's a curve. Remember that the word linear means that it is straight. Non-linear means that it's not straight. It's a curve. So since we drew a curve, this would be nonlinear. So there's our trend. So now we have to estimate on question C, when will the diver be 10 meters above the water? Okay. When will the diver be 10 meters above the water? Well, do we have a 10-meter point on our data? No. We don't have a height that's 10 meters. That's missing. So we can't just write down, oh, it's going to be this time. But we have our curve of best fit to help us estimate as best as possible what it might be. Okay? So, over here, right, we look for 10 meters. We have our curve of best fit and we extended it as much as I could to estimate. If we don't extend it, we can't estimate. So I extended my curve of best fit and I'm going to find 10 meters. I'm going to draw a line horizontal to it. Like that. And you'll see it touches right there. That's a point we don't have. But, right, using our curve of best fit, we're saying, hey, if this trend kept going, what's our best guess? So that's what the green line is for. That's what the curve of best fit is for. We use this trend that we see to estimate and guess what could it be. So since it's touching our green line at 10 meters here, like Russell said in the chat, this would be 1.4 seconds above when the diver is 10 meters above the water. So the at 1.4 seconds, the diver will be 10 meters above the water. Okay? And so there we have it. Let me move it up a little bit. Okay? So hopefully that made sense. Once again, we use our curve of best fit or our line of best fit. We use either one of them to help us estimate and determine what a point might be when we don't have it. Because we're saying that the data follows that general trend, right? That trend line or that trend curve. Okay? So, now the next question is, when does the diver reach the water? Well, my question to you is, at what height is it reaching the water? What value of height? At what height does it mean that the diver reached the water? Because we need to know the height value before we figure out what time. So what would be the height value? Any ideas? No one knows the height? Well, what does height stand for here? Isn't this height above the water? I see the right answer in the chat. Someone typed it. That's right, 0. Because if the height is above the water, at a height of 0, you're not above the water. You're touching the water. You're in it. So 0 would be that height where the diver reaches the water. That would be down here. Okay? So Atreyu's gotten it. Russell's gotten it. Rose has gotten it. So that's good. So we have a height of 0. And so essentially that's kind of like our x-axis line. Now the issue here is that, well, the graph doesn't go that far, right? The graph doesn't go that far. But can we use our rulers? Can we use our ruler to try to guess as best as possible what it could have been? So for me, if I were to draw the lines continuously, or the squares, it would be here. Okay, so notice how I've marked ticks for each square that should have been there. And you'll notice for my curve, it hits in between these two. So if I were to keep going, I would have written 1.6 and 1.8. Okay? So approximately 1.7 to 1.8. For me, if I were to write it, it would be 1.75 maybe, right? So the diver reaches the water around 1.7 to 1.8 seconds. Now the question is, how do you know? Well, I extended my curve of best fit until it reached 0 meter height. Okay? So once again, normally many of you would stop drawing the curve of best fit right at that point. But if you are going to estimate, you have to keep that curve going. Okay? Now a lot of people make the mistake and they draw like a straight line like this. Remember, it's a curve. So you're going to kind of follow the natural curve of that line. It's going to have to drop. Okay? So when we start guessing things, right? We need to extend our line of best fit. We need to extend our curve of best fit to guess, right? What it's asking for. So our final portion for your test assignment is going to be, can you give me your best estimate using your line or curve of best fit? You need to be able to do that, or else how am I supposed to know, right? So you need to be able to do that. Okay. That's the lesson for today. Okay. So this was our curve of best fit. Your homework is page 17. Okay. Page 17. I did not print it. It is for homework. It's practicing trends and relationships in your workbook. Page 17 is your homework. Okay? Page 17 is your homework. Let me actually show you guys what that page looks like here. So let me show my window capture. Perfect. That's what we want. All right. So for us, we just finished page 16. So here, page 17. It's going to ask you, for each of the line of the following graphs, draw a line or curve of best fit. Okay? If you think a curve fits better, draw the curve. If you think a line fits better, draw the line. Okay? And be careful. There may be outliers in the data. Okay? Once you do that, you state the trend. Strong, weak. Positive, negative. Strong, weak. Linear, non-linear. Or no trend. And then you have some graphing examples in the bottom here for page for question 10. Okay? So make sure you finish this for homework. Page 17 is homework for tomorrow. So make sure once this class is done, you still have 30 minutes until the hour is finished. Go print out page 17, have it completed, and then I will check it over tomorrow. Okay? So that's going to be it. We'll go through some examples. We'll do question 3.6 tomorrow. Okay? We'll do question 3.6, section 3.6 tomorrow. So finish this page here. Page 17 is for homework. If you don't have any other questions, that is it for today. Short lesson. Rest of the time is for you to finish that homework. We'll continue on tomorrow. Wednesday will be office hours, right? Wednesday will be office hours. And second announcement is that, let me make my face bigger. Second announcement is that your test will be a test assignment. Okay? Your test will be a test assignment, and I will let you know on Google Classroom. It'll be the same format as the quiz assignment. So make sure you just finish it, hand it in, and then I will mark it and then upload it there. Okay? So just be on the lookout for an announcement or a assignment post on Google Classroom, and I'll make an announcement also on my live stream if and when I create that assignment. All right? But other than that, have a good rest of the day. Make sure you do your homework, and I will see you tomorrow. Peace out.